A very good afternoon to all of you. Today I am here to present the topic of carbohydrates. We have already seen part 1 and part 2 of carbohydrates. Now let us consider part 3 of carbohydrates, because in part 1 it was a very basic part that we have dealt along with. In part 2 we went along with monosaccharides only, where we have classified monosaccharides into ketones and aldehydes and ketones, and then we are here now to further explore the carbohydrates. Now one by one we will try to correlate what are carbohydrates. So in terms of monosaccharide we have seen this particular part. Now come to the disaccharide part. What the word disaccharide means? The word disaccharide, it is derived from the Greek word di, it means two, and saccharides means sugar. When two sugars are joined to each other, then we can say it is called as disaccharide. What we can say? It is called as disaccharide. For example, glucose molecules and this glucose molecules, when they fuse to form each other, or when they are fused or they are coupled to each other, it is called as maltose. See this. Structurally, if we see, consider in this way, then we can say that water molecule, when been removed out, then we can say it is called as disaccharide. Why disaccharide? Disaccharide means two molecules of monosaccharides are joined to each other, then we can say it is called as disaccharides. And what is the kind of linkage that takes place? It alpha-1,4 glycosidic linkage. It is a kind of bond which actually helps in attaching the two units of glucose or monosaccharides to each other to form disaccharides, and this is the particular part. A best example is two molecules of D-glucose joined to each other by alpha-1,4 glycosidic linkages to form maltose. Okay, fine. See this. Classification is homo disaccharides and heterodisaccharides. One by one we will try to study. It seems to be a little bit slow today. I don't know what is the cause. Fine. Fine. Now come to the part of maltose, isomaltose and pseudobiose. Structure: two molecules of 2 alpha glucose are been here, 2 alpha glucose are been here, 2 beta glucose are over here. Types of bonding: glycosidic, but where the glycosidic bond is linked, alpha-1,4 linkages is there. Alpha-1,6 glycosidic linkage is present in isomaltose, and pseudobiose, beta-1,4 glycosidic linkages are being present over there. Now, if you see the structure of maltose, then these two glucose molecules are attached to each other with the help of glycosidic linkages, but where it is the alpha-1,4 glycosidic linkage. The alpha carbon has been attached to each other, while in isomaltose, it is alpha-1,6, sixth carbon atom over here. See this. This is the fourth carbon atom of both of them, so therefore alpha-1,4, first 1 and the second one is 4th. So therefore, this is 1,6, 1 and this is 6. 1, 2, 3, 4, 5 and 6. So 6 carbon atom has been attached. Therefore, the type of linkages that takes place is alpha-1,6 glycosidic linkages. While in case of beta-1,4 glycosidic linkages, see this. Beta-1,4 glycosidic linkage. Alpha, when it comes in terms of alpha, you have to put the oxygen molecule downwards. While in case of beta, when you are drawing the structure, the molecule has to be upwards, means two glucose molecules are over here, which are attached to each other. See, all these are glucose molecules only, but the way they are attached to each other will define them in terms of maltose, isomaltose or pseudobiose. Correct? Right. Reducing properties, reducing, all are reducing sugars. Since why they are reducing? Because they can be broken out back into two easy molecules of glucose. Sucrose. Now this is heterosaccharide. There were monosaccharides. This is a heterosaccharide. Alpha D glucose plus beta D fructose. And lactose, beta D galactose plus beta D glucose. Type of linkages: alpha-1 beta-2 glycosidic linkages. Alpha-1 beta-2. See this. This diagram of sucrose is very essential or very clear to understand. If you see, it contains two molecules. One molecule is D-glucose, another molecule is D-fructose. See the structural orientations of D-glucose. 6 carbon atoms over here, 5 carbon atoms over here. And on the linkages that takes place will be from 1 and 2. So 1 alpha, 2 beta glycosidic linkages. Alpha 1, beta 2 glycosidic bonds. While in case of lactose, it is what is it? Beta 1, alpha 4. Beta 1, alpha 4. Say this. The structural orientation over here, or the glycosidic bond between these two molecules are said to be one of the most important point that has to be considered. Okay, fine. Oligosaccharide. The word oligosaccharide derived from the Greek word oligo. Oligo means few saccharides, means sugar. They contain more than 3 to 10 monosaccharides, usually joined by glycosidic bond or linkages. See this. Galactose, again the bond formation, glucose, and bond formation, fructose. The total structure becomes raffinose. One or more than one molecule, 1 to 3 molecules will be very consistently like disaccharides only. Oligosaccharides will be something where the 3 to 10 molecules of the 1, 2 and 3, they are joined to each other with the help of glycosidic linkages, and therefore we term them as oligosaccharides. Polysaccharides. Poly means many. Derived from the means poly. It means many saccharide sugar molecule. They contains from 10 to 100, even 1000 monomeric or monosaccharides units are joined to each other with the help of glycosidic linkages, and therefore it can be very helpful. Polysaccharides are not reducing sugar since the anomeric carbons are connected to glycosidic linkages. Classification: homopolysaccharide, heteropolysaccharide. Made from one type of sugar units, single sugar units के साथ में अगर है तो it will be monosaccharides. Hetero means of course monosaccharide के example starch, cellulose and chitin. While homopolysaccharide made more than one type of monosaccharide units, hyaluronic acids, coordinating 4 sulfates and epenins. So hetero का क्या मतलब क्या है कि it is more than one type of polysaccharides that join to each other, then we can say it is said to be the homopolysaccharides. Sorry, heteropolysaccharides. See this. Structurally, if we see amylose, and this is amyloplectin, starch. Glycogen are known as animal starch, is structurally similar to amyloplectin. See this, structurally उसका similar है, लेकिन glycogen abundant in the liver and muscles and adolescence, it forms glucose which maintains normal blood sugar level and provides energy to us. To this I don't know today. Yeah. The structure of cellulose. Cellulose again is a polymer consisting of long unbranched chain of D-glucose connected to this. Since chain of D-glucose, but where the linkage is? See this linkage. Beta 1,4 glycosidic linkage. Beta 1,4 glycosidic linkages that takes place, and because of that, the attachment of that particular molecule will be helpful. Cellobios microfibrils arrange themselves into thicker bundles called as microfibrils. They are usually referred as fibers. Most animals lack the enzyme needed to digest cellulose, although it does not provide need roughage or dietary fiber to stimulate contraction of intestine and thus help pass the food along through the digestive system. Cellulose is essential for that animal to digest its own food. Cellulose is also important in industry for present in wood, paper, cotton, rayon, linen, nitrocellulose, photographic films, cellulose, etc. Polysaccharide and other than polysaccharide are chitin, inulin, pectin, hyaluronic acids, coordinatin and heparins are also said to be polysaccharides. So that's all we have seen in terms of carbohydrates. For basic lecture we have gone through what are the basic things here in terms of carbohydrates. Secondly, in the second lecture we went along with classification of carbohydrates in terms of monosaccharide, disaccharide, oligosaccharides and polysaccharides, and we have dealt in greater details of monosaccharides in the second part. This is the third part wherein the carbohydrates are being classified as disaccharides, oligosaccharides and polysaccharides with their examples. Basically the linkages today we have seen in terms of what are the linkages between the two and what is the position of the carbon and the next molecule, and based on that alpha or beta configuration can be easily dealt. Okay, so, thank you.